Ever wonder just how big the universe really is? I mean, really big. It's a question that can kind of break your brain, right? Well, today we're going to try and wrap our heads around it. And our journey, believe it or not, starts right here at home.
Yeah, Earth. This is our starting point. And it's not just a rock floating in space, is it? Think about it. It's everything. Everyone you've ever known, everyone who has ever lived, every single story. It all happened right here, on this one little sphere. Keep that in your mind as we start to pull back.
All right, so let's take our first step off this rock. We're not going too far, just to start. We're heading to our closest celestial buddy, that familiar face you see in the night sky. The moon. I mean, it feels close, right? You can look up and see it almost any night. But you're going to see that close is it's a very relative term when you're talking about space. So how far is it really? 384,000 kilometers. That's a huge number, and honestly, it's kind of hard to picture. So let's try to put that into perspective, shall we? Okay, get this. If you hopped in a car and drove at a steady 100 kilometers an hour, no stopping for gas, no bathroom breaks, it would still take you over 160 days to get there. That's more than 5 months of nonstop driving. And all that just to reach our closest neighbor. We've barely even left the driveway. All right, buckle up, because the distances are about to get, insane. So big that using kilometers is going to get really clumsy, really fast. We need a whole new measuring stick. And here it is. It's called the astronomical unit, or AU for short. It's actually a pretty simple idea. 1 AU is just the distance from Earth to the sun. Easy, right? Except that 1 unit is about 150 million kilometers. That's a distance so big it takes sunlight over 8 minutes just to travel it. Now look at these numbers. Even with our new measuring stick, the scale is wild. If you could fly a commercial jet to the sun, you'd be on that plane for about 19 years. And a trip to Mars, our next-door neighbor, even at its closest, we're talking over 50 years. Our solar system is mostly just empty space. It's staggering. Okay, let's keep going, all the way out to the edge of what we'd call our solar neighborhood, Neptune. It's 4.5 billion kilometers away. And get this, even sunlight, the fastest thing there is, takes over 4 hours to get there. You could watch a couple of long movies in the time it takes for a sunbeam to reach Neptune. That's wild.
Speaking of going out there, way back in 1977, we sent a message in a bottle out into this vastness. It was the Voyager 1 probe. And after it finished its main job, scientists gave it one last, truly profound task.
Yeah, at the suggestion of the great astronomer Carl Sagan, NASA decided to do something they'd never done before. They turned Voyager's camera around for one final look back at where it all started. And how far away was it when it took this picture? 6 billion kilometers. From that far out, our entire planet, everyone, and everything we know, it shrinks to just a tiny, almost invisible speck of dust. And that's the famous picture, the pale blue dot. Carl Sagan said it best. Look again at that dot. That's here. That's home. That's us. I mean, wow. All of our everything on that little speck, just floating in a sunbeam. It really puts things in perspective, doesn't it? So that photo from Voyager was pushing the limits of our solar system and our measurements. You know what that means? Our measuring stick, the AU, is starting to get a little clumsy again. To go any further, out to the stars, we need something even bigger. And that's where the light year comes in. Okay, let's take a trip to the next star over, Alpha Centauri. If we try to measure that distance in kilometers, look at that number. It's just a ridiculous string of zeros. 41 trillion kilometers. It's meaningless. But in light years, it's a nice, clean 4.4. And that tells you something real. The light from that star has been traveling for 4.4 years just to reach us. All right, you ready for another jump? A huge one. We've gone from planets to stars. Now let's talk about the entire city of stars we call home, the Milky Way. Our galaxy is 100,000 light years across. Just think about that. If you were traveling at the speed of light, it would take you 100,000 years to get from one side to the other. It's got hundreds of billions of stars. So in all of that, how much of a mark have we made?
Well, This is it. It's called the human radio bubble. It's how far our first radio signals have traveled out into space, and it's only about 100 light years across. So to pretty much our entire galaxy, we're completely silent. Our entire existence is just a tiny, faint whisper in a vast cosmic ocean.
Okay, time for the final, biggest zoom out. Because it turns out even galaxies don't just float around randomly. Nope, they're grouped together in even bigger structures. You can think of it like cosmic neighborhoods or cities or even continents. So here's our cosmic address. Our galaxy, the Milky Way, is part of a little neighborhood called the Local Group, which has about 50 galaxies. That group is part of a much bigger city, the Virgo supercluster, with about 100 of those groups. And even that is just one small piece of our home supercluster, Laniakea. Laniakea, it's a Hawaiian name that means immense heaven. And yeah, that feels about right, doesn't it? It's this gigantic structure that contains the mass of something like 100 million billion suns. The numbers at this point, they're basically beyond human comprehension. And that brings us to the very end of our journey. Now, this isn't the edge of the universe itself. That's a whole other can of worms. No, this is the edge of the observable universe, the edge of what we can possibly see. The size of the part of the universe we can see? About 93 billion light years across. Now, you might be thinking, wait a minute, I thought the universe was only 13.8 billion years old. How does that work? Well, it's because the universe has been expanding the whole time. Space itself is stretching, so the light from those really distant objects has had to travel across an ever-expanding distance to finally get to us. And that brings us to the final, really mind-bending idea. We've traveled all this way, from our home, past the moon, out to the stars, across galaxies, only to find a boundary. Not a wall, but just the limit of what we can see. The space beyond that edge is literally expanding away from us faster than the speed of light. We will never see it. Which means our entire observable universe, as ridiculously, incomprehensibly huge as it is, it might just be one tiny bubble in a truly infinite cosmic ocean. So it kind of leaves you with one big question, doesn't it? What lies beyond the edge?